There are millions of liters of water that are used to climatize the cloud. And that has affected many populations around the world. We have seen that in certain cases, we cannot build new housing projects in cities because the grid is already stretched by the use of energy by the data centers. So we have to start to think about certain limits and regulations. And that's precisely what the industry doesn't want.
Welcome to Art is Not a Thing, the podcast series about art as a practice of critical inquiry, knowledge production, and world building. My name is Anna Carabelea, and together with my colleague Hanna Balber, we discuss with artists and researchers whose work questions and reimagines our practices in and of the world. In this episode, we explore the impact of our digital infrastructure on the environment. Even though the so-called cloud sounds like something light and invisible, it is actually supported by massive data centers that consume a lot of energy, water, and raw materials. Spanish architect and researcher Marina Otero Verzier highlights this issue in her project Computational Compost, demonstrating how digital technologies can be integrated with natural cycles. She has developed a prototype that uses the heat emitted by computers running simulations of the universe's origin to power a vermi-composting machine with life forms and microorganisms. For this project, Marina received an honorary mention at the STARS Prize 2025.
You've been exploring the intersections between digital infrastructures and the climate catastrophe for a while now. How did the idea for computational compost emerge?
Yeah, so I've been looking into the environmental impacts of digital infrastructures, in particular data centers. Last years have been pretty much focused around lithium and data centers. So I had an award from Harvard that allowed me to travel to many different countries to seek for the most eco-social designs for data centers. And all that information came into place somehow in a prototype that I developed with the Donosti International Physics Center. And this was a commission for an exhibition at Tabacalera in the north of Spain, in Donosti. And what we tried to do is to address the environmental impact of the infrastructures that these laboratories, that are scientific laboratories, have, because they have supercomputers. And the supercomputers are incredible machines that allow you to make very important discoveries, but at the same time, they also have huge impacts in the territory.
You've said for a long time we have created this image of the digital world as the cloud. Why is this metaphor misleading?
Well, it's a great metaphor for a PR campaign. So I congratulate those who came up with that idea, because actually it's somehow something that stays with us. And actually it's very misleading, because it's nothing ethereal about the digital infrastructure. It's actually very material, it's very grounded. And it depends very much on the ground and the extraction of the ground. So from the elements and minerals that are needed for the entire supply chain connected to the digital infrastructure, to the operation of all our devices, depending on infrastructures like the data centers that require a huge amount of energy, water, and they produce emissions like CO2, heat. So at the end, the cloud is very much heavy. We were sold this ethereal floating entity, and it actually is very, very heavy infrastructure.
Could you just briefly describe, we will dive into the details a little bit later, what exactly is computational compost and what questions does the project address?
Yes, so computational compost is a prototype that is composed by a vermi-composting machine that I will explain, and a film. And the film is directed together with Document and talks about the impacts of digital infrastructure, but also our dependency on accumulating huge amount of information and questions for whom this information is stored and who benefits for it. And the machine is a prototype especially made for the Donostia International Physics Center and its supercomputer, because right now the heat that is emitted by the servers, that heat goes directly to the garden nearby and is affecting a tree. Well, in particular, it's affecting many, many lives. But in particular, there's this story of a tree. It's a loquat tree that blooms earlier in the year because it's confused, because all the heat coming from the supercomputers comes out to the real world and affects this vegetal life. It represents the way in which digital infrastructures have an effect in climate change. They contribute to climate change. They contribute to the global heating. They contribute to the death, or at the end, also the altering of many lives. So the idea was how we can take this heat and do something different about it that will be more a symbiosis or a more fair relation between technology and biology. And that's computational compost.
So what are the main ecological consequences of the current data storage infrastructure?
There are several things. So on the one hand, the servers, they require a lot of energy to operate. And that's even growing due to AI, because the microchips that are used for AI and the type of equipment is even more energy intensive. You use the energy for powering the servers, but then the servers in their operation produce heat. That heat has to be dissipated, because otherwise it will affect the functioning of these servers. So you need to climatize. And for climatizing, cooling down the entire room, that is what has been happening so far and is the most used system. In these cases, to cool down the entire server room, you are using energy and you are using water most of the times. And that water is actually drinkable water. In the worst cases, there are millions of liters of water that are used to climatize the cloud. And that has affected many populations around the world. We have seen that in certain cases, we cannot build new housing projects in cities because the grid is already stretched by the use of energy by the data centers. So we have to start to think about certain limits and regulations. And that's precisely what the industry doesn't want. So I'm very much involved in forms of activism and research, and also forms of advocacy, trying to create forms of legislation around this industry. So I think those are very important. First of all, that we all understand the implications of our digital lives and what is happening with AI. Second, that we try to regulate what is happening at the moment, and at the same time, think forward and find ways to design this digital infrastructure differently.
Also, in many scientific disciplines like physics or astronomy, storing huge amounts of data is essential. But what happens when the infrastructure needed to sustain scientific progress becomes unsustainable? And that brings us to your collaboration with the Donostia International Physics Center. What was the starting point for working with them, and what did you find particularly interesting about their work?
So in my conversations with the Donostia International Physics Center, I try to understand what are the most data-intensive activities they are having. And some of them are running these simulations of the origin of the universe that they are running in their supercomputers. And that requires, as we have seen, a lot of energy and resources. But in this case, what I also found interesting is that all the heat goes to the outside and is affecting this tree that we mentioned before. So to me, it was like, well, our quest to learn about the origins of our life is actually affecting life. So it was a paradox that to me is at the core of many of the scientific advancements we have and the digital infrastructure itself. By creating alternative worlds, we are also putting at risk this very world that we all share. So in conversation with the scientists, we say, okay, what if we design a prototype that reuses the heat? So instead of going outside, it does something else that has to do with this relation between biology and technology. So what we did, we created a replica of the supercomputer through a Raspberry Pi farm. It's not as powerful as the supercomputer, but allows to run the simulations of the universe. And this Raspberry Pi farm is running these simulations and is part of a vermi-composting machine. So we identify the points of the Raspberry Pis that are getting hotter by doing the calculations, the compute. And then these heats, we redistribute it and we transfer it to the other side of the machine, or the prototype, that is full of earth and microorganisms and worms. And these worms and these microorganisms actually thrive on the energy, the heat that comes from this Raspberry Pi farm by these simulations of the origin of the universe. So at the end, this prototype is a vermi-composting machine that transforms computational power in compost through the work of worms that also enjoy the process. And after a few months running, we take this super fertile compost and the worms and put them in a nearby garden that was a community garden. So it actually helps grow other life. So in certain ways for us, it was this reflection on how our technologies could actually enter in a more symbiotic relation with biology and help think about other systems of coexistence between the digital and the more physical world. At the same time, there is something a bit more like a cautionary tale out there, because we also can think about this system as almost autonomous, saying if we don't do anything to improve the current conditions under which we develop our world, if we don't think about other ways of being in the world that is not so extractive and polluting, maybe what we end up having is machines and microorganisms inhabiting and collaboration, but perhaps other lives, like including human life, is out of the equation. So this machine also talks about other relations that are more than human, in this case, even a-human. It's both a source of optimism to think we can design things differently, but it's also a cautionary tale about if we don't, it might be tough.
Marina teaches at Columbia Graduate School of Architecture, Planning and Preservation in New York and the Harvard Graduate School of Design. In 2022, she received Harvard's Wheelwright Prize for a project on the future of data storage. Her work, Computational Compost, was first exhibited at the Tabacalera Cultural Center in San Sebastián, Spain. Marina has also contributed to Chile's first national data centers plan. In her current book, she explores alternative models for data centers and new paradigms and aesthetics for data storage.
In the short film accompanying the project Computational Compost, we see a quipu, which was a method used by the Incas and other ancient Andean cultures to keep records and communicate information using string and knots. What is it all about to incorporate this quipu into the project, and what drew you to this ancient technology?
I was totally fascinated by quipus, and I recognized my ignorance because I didn't know what they were until during my research trips to Chile, both around lithium and the digital impact of these data centers, the impact of these data centers in the environment. I went to visit the Museo Chileno de Arte Precolombino, Pre-Columbian Art Museum, we translated. And they have one of the most amazing examples of a quipu. So these quipus, as you said, are recording devices that in many cases have been compared to the first computers because allowed you to, in a way, compute, calculate, but also data centers, I will say, because they allow populations, especially the quipu camayocs, that were the ones who made these quipus and carried the quipus, they were recording information in this system that is made of cords. You record or you remember by touching, by identifying the different types of knots, their direction, but also the color that the fibers, camelid fibers, have. So they are extremely sophisticated devices that were used to account for taxes, let's say, but also tales and much more complex stories around the Inca Empire. Well, the colonizers, the Spanish colonizers, my ancestors went and destroyed many things, among them also these relations with quipus, because for them were threatening in many different ways. And one of them is that they could use by the local population to carry messages that will lead to revolt. And it's because the colonizers were not able to read the language of the quipus. They preferred to ban them and later destroy them. So actually, very few quipus were left. Most importantly, even though there were some translations, in a way, records of saying what type of information had this quipu, so you could make the equivalent, those relations were lost. So that information was lost. So now there are a few quipus that are still being stored in museums, in different institutions. So many scientists are trying to retrieve the information to understand what is actually the code, crack the code of the quipu and understand all the information that was stored there, because they think that that will help to understand the Inca Empire in a completely different fashion. It's impossible to somehow understand fully what is there. At the same time, it talks about how we store information for the future and how much, at the moment, data we keep just for the fear of loss or just in case because might be helpful for the future or any other reasons that we have, both at the level of institutions, corporations, obviously, that benefit from that, but also the individuals, how we store so much. And the question is, who is going to be the recipient of that information? And how do we know that it will be read as we intend it will? Actually, as the quipus, that now they are not able to be read completely. Data also decays over time. The codes are no longer operative in the same way because devices get obsolete, softwares as well. So both hardware and software change over time. Migration of information from one system to the other always involves loss. So at the end, there is an information lost in all these processes, and data doesn't stay exactly the same for centuries. So in a way, the story of the quipu, again, is a cautionary tale about the compulsion to accumulate so much data. And at the same time, think, for whom is that data? Who will be able to read it? And actually, all the environmental implications that have the storing and managing of this data, is it worth it? For what exactly we are making all this endeavor and who is actually benefiting from that? So the quipu allow us to have that conversation.
So the fate of the quipu could foreshadow the fate of our own digital records. And in the installation or in the project, we see that film, that beautiful short film and the prototype together telling the story of data storage, sustainability, and the loss of information. The project is highly collaborative. It took a multidisciplinary team to create Computational Compost. Why do you think it's important for artists and scientists to work together in addressing the climate crisis?
I think we all have different forms of creativity. It's not only artists that are creative. I think scientists, in order to find ways to see differently, to carry on with these experiments, and they are extremely creative. But we have different ways of approaching creativity. We have different languages, and sometimes we see things differently. So I think what art does is also challenging certain preconceived ideas, helping see things from different perspectives, and opening up other ways of thinking, sensing. So for me, it has been an incredible experience to be able to work with scientists. They are extremely knowledgeable. Yeah, I think has been a fantastic collaboration. And to me, it's not the way in which I was used to work. And since then, I think has opened a field of practice completely new to me, and that now occupies most of my time.
What would you say, what is the main goal of the project?
To make us reconsider our relation with data and our quest for more in certain ways. At the same time, I think it's a way of considering that biology and technology could work alongside in ways that are not damaging the planet. So considering other types of relations. But primarily, it's optimistic in a way. It's being optimistic about, hey, we can redesign these things. it seems impossible to change the system around what a scientific laboratory does and how it operates. So what Google, Meta, Amazon does. And I think the daring, let's say, positioning of artists and activists allows to say this could be done differently. And that's the project about, saying it's not going to be solving all the issues we have, but it's planting a seed of, oh, yeah, maybe we can redesign this entire system and we can be very creative in how to do it.
Wonderful. Thank you very much for the conversation.
Thank you, Hanna. It has been wonderful to be with you.
That's it for today. Thank you so much for tuning in and hope you enjoyed it. Today's episode was brought to you by Radio Ö1 and Ars Electronica. Join us next month for a new episode, and in the meantime, follow us or share the show with someone you think might like it.